We've come to Ecuador to try to find goblet spiders. One of the reasons that we chose this particular family of spiders is that they're so poorly known on a global basis. That's because they're considerably smaller than the animals that arachnologists typically deal with. The average spider that you collect is somewhere between 4 and 8 millimeters. These animals are half that size or a third that size. A majority of the goblet spiders are ground and litter-dwelling species.
Right now we're collecting litter and we're sifting through it to concentrate the amount we can collect. So basically just collecting all the litter we can so we get more spiders.
Probably our bag's worth here. It's moist but not muddy. If it's too dry, it's no good. If it's too wet, it's no good. This is okay. Field work is a messy enterprise. And it is highly serendipitous, which is part of what makes it fun.
I always look a little bit, if you see one, then it's a good sign. It keeps you from, you go on a little bit more if you see one. Oh. Okay, that's it. That's one of them. So this is what we're looking for. It's orange. It's really small, 1.23 millimeter.
As biologists, we want to know every species on the planet.
That's funny, Neefy. Yeah. Well.
And so we've undertaken the Planetary Biodiversity Inventory Project to take groups that are poorly known, like goblin spiders, and bring them up to the level of the better known groups so that we are better positioned to conserve biodiversity. One of the advantages of being on an expedition with a sizable group of people like we have here is that people have different experiences and different techniques. Depending on the day in person, any one of those results might be better than the others. And so being able to have different people doing them all in slightly different places really increases the chances of finding what you're after. We've been here about 5 working days at this point, and I have not yet recognized any species as one that we've studied before. We won't know the details until we get back to the lab and good microscopes. But this could be cool.
After we came back from Ecuador, we brought back with us some specimens of the spiders we collected on the field. And then we go into really detailed analysis of the spiders to describe new species. We look at the spiders under the scanning electron microscope, which gives you a really precise photograph of the specimen you're looking at. Here we have a view of the complete spider. So this is a male we collected in Ecuador. Here you can see the carapace, so the head of the spider. We have 6 eyes. And this one is very nice because in the middle there's a row of ornamentation and then they turn into lines. So this is a good characteristic to recognize the species. All the spiders we collected are new species. So they've not been found elsewhere. And we were quite surprised because indeed you could expect them to be a little bit in Peru, a little bit in Colombia, but so far we have all new species in Ecuador, yes.
Ecuador has much larger number of Argonne spiders than anyone ever anticipated. But knowing the number of species in a given place is only the beginning of understanding biodiversity. If you have an area that has 200 species, but all 200 of those species are actually widespread over all of Amazonia, say, then that area may not be as important. Whereas an area that has only 75 species, but of those 60 occur nowhere else on the planet, then you have reason to say this is an important area to save. Conservation decisions are always judgments. Obviously, we cannot save everything on the planet. We have a triage situation. We have to decide what is most important to save. But there's no way of knowing what to save if you've never managed to collect them and know that they're there.
Photograph of the specimen you're looking at. Here we have a view of a complete spider. So this is a male we collected in Ecuador. Here you can see